All right, so today picks up right where yesterday left off. With this definition, this is the composition of two functions. Just kind of like yesterday, how we had something that I said it's in a big box on page 416. This is also a pretty large section on 416, so if you'd like some more details, check that page out, or if you just don't feel like taking notes, check that page out. But a composition of functions looks like this. Basically, you're putting one function inside of another function. Okay? So we're defining a new function, h of x, and we would call this f of g of x. Now, when you're evaluating something like this, let's say you're plugging a number in like 4, you would plug 4 into the g function, and then you'd plug that answer into the f function. Someone told me a funny example, and I don't know, it always stuck with me. Have you guys seen those things? They have them around Thanksgiving. It's like a turkey, and then inside the turkey they put a chicken, and then inside the chicken they put a duck. Have you ever seen that? A turducken, it's called. Have you ever seen that? Yeah. That's kind of what this is, okay? They're starting with a function, they're putting it in another function, they're putting in another function sometimes. This one is only 2, so it'd just be the turkey and the chicken inside. But I don't know, that's kind of a funny example. So you're starting with something, evaluating it, and then putting it in something else. I'm not sure the logistics of the turducken. Apparently it's really good, though. Who? I don't know who that is. Like the football player? All right, cool. Awesome. All right. Just like yesterday, we have to consider the domain for these functions. So the domain of h is the set of all x values such that x is in the domain of g, and g of x is in the domain of f. So that's kind of a fancy way to say basically you have to start inside and work your way out. So you need to think of the x values that will work in g, and then once you evaluate g, what values will work in f. So you kind of work your way out to find the domain, but we will look at some examples for that as well. Any questions just about the general concept of a composition of functions? All right, so this first one, remember I said you start in the middle and you work your way out. So first we're going to start with g of x. G of x we know is x minus 2. And we're essentially just putting this value in for the x in the f function. So you're just starting on the inside with the g of x. Well, g of x is x minus 2. We're going to plug x minus 2 in for the x in the f function. So it'll look something like that.
Wait, where did this go?
So we took this x out, kind of just left the parentheses, and then inside of it we put the g function, x minus 2. So that's right here. All right, then you can simplify it from there. We know that anything with a negative exponent, we'll move it to the bottom of our fraction. Or if it's in the bottom, it will move it up to the top. So the x minus 2 is going to go to our denominator. So we have 2 over x minus 2. Now we have to think about the domain. The domain here is all real numbers except x equals 2. Now, why is it all real numbers except x equals 2?
2 minus 2 equals 0.
Because 2 minus 2 equals 0 will have a 0 on the bottom. Good. Now, let's look back to our original functions. Do you see this is the same thing as 2 over x? Right? You can just move the bottom. So for for just the f function, we can't have a 0. But remember, what you're plugging into the f function is the g function, so we can't put a 0 into the f function, so you have to figure out what makes the g function 0, and it's 2. Okay? Questions on this?
So the answer is x minus 2.
Yep, this is the answer. And then it said state the domain, so we can plug any number into here and get an output except 2. It would give us undefined. So we're starting with those same two functions, but now we're putting the f function into the g function. So I'm going to start with the 2x minus 1. I'm going to take that value and I'm going to plug it in for the x in this function. So I'm taking this x out and I'm replacing it with 2x to the negative 1. So all I'm really doing is taking that f function and I'm just subtracting 2 from it because the f function now goes here and then minus 2. So again, the one that's inside is the one you're plugging in. So you're taking this one and you're plugging it into this one. How'd they get that answer? Yeah, we have a negative exponent, so we take the reciprocal. That's all you can do in this one. It doesn't change this negative 2. It doesn't move the 2 to the bottom either because it's not an exponent. It would need parentheses in order to move the 2 down. So we're just taking the x down, taking the reciprocal of it because it has a negative exponent, so it's just essentially going right under the 2. And that's our answer. That's g of f of x.
Why do you take the parentheses off?
I'm not sure what your question is. What parentheses?
Because, it's because g of x is on the outside. So why are you going to do the parentheses?
Yeah, so you're plugging this function in for x, so if you wanted to put parentheses around this whole function, that's fine. You could. It's not going to change anything in this one. Sometimes it does. It's a good habit when you're plugging stuff in to keep it in parentheses, but yeah, I just didn't use them in this one. All right, domain, what are our restrictions? What number can we not plug in? 0. Wonderful. All real numbers except x equals 0. We're plugging 2x to the negative first power in for the x and 2x to the negative first power, right? So you would just put right around. Yep, it is tricky. So basically, you're plugging this function into that function for the x value. If it was f of x times f of x, that's what it would be. But this is a composition. So we're taking one function, just like the turkey and the turducken. You're taking, yeah. You're putting f of x in for the x in f of x. It's kind of tricky. Yep. We can simplify it from there. So basically, this negative exponent around this expression, we'll move it to the bottom. But now what happens to this x? Yeah, you'd move it back to the top because it's negative.
Why move it back to the top?
Because it's negative. So this negative on the outside caused me to move this whole expression to the bottom. However, it still left me with that x to the negative first, so now I move it back to the top. There are multiple ways to simplify this. I'll take you all the way to the end. The 2's cancel, and you're just left with x. Another way to simplify this would be to take everything inside the parentheses to the negative first power. So that would be 2 times 2 to the negative first times positive, or x to the positive 1, because the negative times the negative. And then you just move that one down. So then you'd have 2x over 2, and then those would cancel. So there's multiple ways to simplify this, depending on how you want to handle those exponents. But you do end up with just an x. Any restrictions? Let's go back to our original function. Is there anything we could not plug in right there? 0, right? That's the same thing as 2 over x. Up here? Same thing as 2 over x. You got to look back to your original functions for the domain. So x cannot be 0. Just because of what we started with. See the zeros on the bottom. So even though it simplifies to just be an x, along the way you would get some undefined answers if you plugged a 0 in. So just be careful on that domain. Questions? So you work your way out. So I'm going to start with g of x, which is x minus 2. I'm going to plug that in for the x in g of x.
So what about the other x?
Well, you take it out because you're substituting it in. So you take this x out, and in its place you put x minus 2. Right, it's kind of tricky. This does take some getting used to. That's why I told you guys yesterday. Yesterday is kind of the warm up. This is where it gets a little heavier. All right, you just subtract the 4, or subtract the 2 is negative 2 minus 2 is negative 4, and then we don't have any restrictions here because you could take anything and subtract 2 from it. It's not an issue. All right, I do want to add one type of problem that you might see. I see the class before us did it, so we'll just do their same example. I'll cheat. So I'm going to have Q and J. Now, you might see problems where it will say something like this. So now instead of x, they want you to start with a 2 in your first function. So when you have something like this, remember I said you kind of work your way inside out? You would start by plugging 2 in to the q function. So I'd say q of 2 equals 6 times 2, which is what? 12. However, we don't want to just know what q of 2 is. We want to know what j of q of 2 is. But q of 2 is now 12, right? So that's the same thing as plugging 12 into the j function. So it would just be 12 minus 5.
Wait.
So you're just working from the inside out. Which would give you what? 7. Good.
You had to find the right.
Nope. If they're actually telling you what x to plug in, you just start in the inside, the innermost, and work your way out. Any questions on this? It's kind of tricky. That's why I want you guys to have like a half hour to do homework in class. We'll do questions on the board if you guys come to one that is stumping you. But here's your assignment for today. Very similar to last night. It's just kind of the sections that we skipped. Again, they are odd in the first section and all in the second section. So I'll give you guys the answers before you head out of here for 48 through 51, just so you have them over the weekend. Any questions?